Have you ever woken up early in the morning, looked outside your window, and seen the world covered in a thick white veil? It feels quieter, slower, almost frozen in time. That mysterious scene has a name: fog. But what exactly is fog? Is it smoke? Is it a cloud? And more importantly, how does it form? Today we're going to uncover the science behind one of nature's calmest yet most fascinating phenomena. Let's start with a simple truth. Fog is basically a cloud at ground level. Yes, that's it. There is almost no difference between the clouds you see in the sky and the fog you walk through. Both are made of tiny water droplets suspended in the air. The only real difference? Clouds form high in the atmosphere. Fog forms right near the Earth's surface. When fog forms, visibility usually drops below 1 kilometer. If visibility is slightly reduced, but not that extreme, we call it mist. But for fog to appear, several important conditions must come together. The air around us isn't empty. It contains nitrogen, oxygen, and always some amount of water vapor. Water vapor is invisible because it's in gas form. It constantly enters the atmosphere through evaporation from oceans, lakes, rivers, soil, and even plants. Here's the key idea. Warm air can hold more water vapor. Cold air can hold less. And this difference is where fog begins. As air cools down, its ability to hold water vapor decreases. At a certain temperature, the air becomes fully saturated. This temperature is called the dew point. When air reaches the dew point, it can no longer keep water in vapor form. The water vapor begins to condense, changing from gas into tiny liquid droplets. But condensation doesn't happen in empty space. Tiny particles in the air, like dust, pollen, or microscopic pollutants, act as condensation nuclei. Water vapor gathers around these particles. Millions of tiny droplets form, and when enough of them collect near the ground, fog appears. The most common type of fog is called radiation fog. It usually forms under these conditions: clear skies, light or no wind, long, cool nights. At night, the Earth's surface loses heat by radiating it into space. As the ground cools, the layer of air touching it also cools down. If that air is moist and cools to its dew point, condensation begins. By early morning, thick fog can cover fields, valleys, and rivers. This is why fog is often seen in rural areas, near bodies of water, in valleys, during early morning hours. Once the sun rises and warms the surface again, the fog slowly disappears. But what about the dense fog often seen near oceans? That's called advection fog. This happens when warm, moist air moves over a colder surface. For example, when warm air passes over cold ocean water, the lower layer cools rapidly. If it reaches the dew point, condensation occurs, and fog forms. Advection fog can last much longer than radiation fog, and sometimes covers large coastal areas for days. It can significantly impact marine transportation and air travel. In mountainous regions, another type of fog forms. When moist air is forced to rise along a mountain slope, it expands and cools. As it cools, condensation begins. The result? A thick layer of fog that seems to cling to the mountain. In reality, it's simply a cloud that has reached ground level. Fog reduces visibility because its tiny water droplets scatter light. When car headlights shine into fog, the light doesn't travel forward efficiently. Instead, it spreads in many directions. That's why high beams can actually make visibility worse in foggy conditions. This is also why fog can make driving, flying, and shipping dangerous.
Fog is not just a beautiful or mysterious weather event.
It plays an important ecological role. In some coastal deserts, certain plants survive almost entirely on moisture collected from fog. Fog can influence agriculture, ecosystems, and even local climate patterns. So the next time you step outside into a foggy morning, remember, you're walking through a cloud. A quiet, slow-moving, scientific masterpiece created by temperature, moisture, and physics. Nature often hides its most powerful processes in its calmest moments. If you enjoyed this exploration of everyday science, don't forget to like the video and subscribe for more fascinating explanations of the world around us. See you in the next one.